So what I'm going to do, guys, is I'm going to start working on my shell code up on the screen. If you want to see the process I'm going through, try to get some hints. You're welcome to look at that. If you'd rather do it all on your own, keep working on your own stuff, just avert your eyes and keep working on your own files.
Hey, Corey.
Yeah.
I'm a bit Linux text editor literate. I'm trying to use that Nano.
Oh yeah. Sorry, I should have told you guys that. So in Nano, there's lots of text editors use Linux, and people say VI or Emacs, blah 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 blah. Nano is your easiest choice. Okay, there's nothing wrong with using Nano. I use Nano all the time. you just do like nano text file, opens it up, and then you just do Control X to save and exit. Control X. Control X. X is in. So yeah, sorry, I didn't bring that up, guys. It's because you guys are a little bit ahead, and I hadn't even thought about telling you how to use a test harness. But to use the test harness, you do it like so. Let's say that you have your Perl script ready. So this is my Perl script that I made, after making my shellcode. This is just printing out the hex bytes. Now I want to test this out with the test harness to see if it actually works. So first, just make sure you compile the test harness with TCC, not GCC. And you can just do it like so. You can either run the script and output the contents, the output of the script to a file, like a shellcode.bytes file, and then pass that to the shellcode harness, or you could just run the script directly to the shellcode harness. The key here is use these backticks, which is the substitution operator, which is basically just make the first line command line argument for this program, whatever the output of this program is. So you could also do like, let's say this is my shellcode, just a bunch of knobs. Oh yeah, okay, so just hit the knobs and then eventually exit it, that's fine. You could do it like so. Blah contains my shellcode opcodes, and I can just do backtick. Backtick is important, fronttick won't work. Backtick is a substitution operator. So basically, just think that you're running shellcode harness, and the first command line argument needs to be all of the hexadecimal bytes of your shellcode, all the binary bytes of your shellcode.
Is the shellcode harness, that's just a C program that interprets the assembly code?
Yeah, I'll show you what it does. It's really awful to look at. If you ever see code like this in a project you are looking at for a sponsor, you should be very scornful. Because basically I'm using really nasty pointer arithmetic to change my return address. So I'm basically setting my own return address to the pointer to the first command line argument. Now here's a tricky thing too. It's like, okay, I'm going to do my shellcode harness. All right. Didn't appear to do anything. Well, that's just because I just executed my shell again, and the prompt is exactly the same. So if you're unsure whether or not it's actually running, one trick you can do is just change to like the C shell, which has this nastier command prompt thing, and then just run it again. And it's obvious that you've executed /n. Not necessary, but just keep in mind if you're like, man, this should be working, but it's not working. It might be working, and you just don't even realize it.
So we're trying to take this and put it in the same place that we did the last exercise, right? In the simple login code?
No, we're not going to use the shellcode here that you made here for the simple login program. We're going to use it on another program. But your shellcode already working?
I think so. You can.
And if it runs in the harness, then.
Right, but I mean, I think I got all the zeros out of that.
Did you try it in the shellcode harness?
Yeah.
Okay, and it worked? So yeah.
Okay.
Because it would fail in the harness too if there were zeros.
This is my.
Yeah, that's perfect. Okay. Who here has working shellcode? Who does not? Who feels like they are close? Josh?
I'm catching up.
Okay.
We're good there.
For those of you that have already got your shellcode working, I will present to you your next challenge so you can start working on that. And if you go into the labs directory, /home/unit/labs, you will be exploiting, this program. So what's different about this is it's simpler than simple login, just to sort of simplify the exploitation process. Notice that the buffer overflow is happening on the command line argument. So you're going to have to pass your payload similar to how you do with the shellcode harness with the backticks and the cat. So like /basic vuln backtick cat payload backtick. Not like with the angle bracket operator. So do not do this. That won't work because it's not reading any data like via git call. All the data is coming in via the command line argument. So instead, you will have to be using your payload like that. So add that to your list of commands and make sure you're trying to use that one. And make sure you note to yourself that these are backticks, not front ticks, not regular single quotes.
But this would be the payload, including manipulating the registry and all that stuff.
Yes. For those of you still working in your shellcode, that's fairly okay. But for those of you that are already done, I want you to start trying to exploit this and get this to run the shellcode that you just developed. Okay, so you're going to have to go through the payload building process, just like we did for the simple login. So your payload is going to need to be how many bytes total? 72. 64 bytes to consume the buffer, 4 with the save frame pointer, and then 4 more for the return address. Inside that initial 64 bytes will need to be no-ops and the shellcode you just made. So you'll have to figure out how big is the shellcode you just made. That way you know how many no-ops to add as padding. And then you'll have to load up the program in the debugger and figure out where your shellcode is and where your no-ops are on the stack when you insert the payload into your program. And then obviously set the return address and look at that.
Is there a certain place that you want us to include it, or just? Do you want it just so when we run that program, it'll execute the code instead of whatever that is?
Yep.
Thank you.
Yep. So one thing to be aware of, guys, is when you're working on these exploits, the stack addresses will vary slightly when you're debugging the program and when you're not debugging the program. So when you go to look for your payload in the debugger, when you just run it on the command line, the values, the stack addresses will actually like shift around a little bit. It's kind of annoying. So the best way to combat that issue is to try to pick your return address in the very middle of your no-ops. That gives you the most room on either side for error.
Dash something or other now.
Yeah,
There's no way to convert that. I didn't do this on purpose, it's just what I'm doing.
yeah. I don't like AT&T syntax. Some people like it. If you want to change it,
I would like it. That would be good.
are you running as root or student?
Student.
Okay.
I'll try.
And you can put it in. You put it in the beginning because GDB is AT&T syntax by default. So if you add it to this .gdb init file, it'll do that every time. It's just commands that run every time GDB starts. But it's handy because if you're like me, ATT syntax is kind of hard to understand, so I always prefer Intel syntax.
Does the obj dump program has an option for listing in detail format too?
Okay. Yeah. Usually with obj dump, it's like I'm looking at something simple enough where I don't really care as much. But where I'm debugging, I really like to see everything in Intel syntax. But some people, they would crucify me for saying I don't like AT&T syntax. It's kind of like one of those Emacs or VMAX things, of which I prefer Emacs. I mean, tags is just so good. Nothing like tags. So just so everyone knows, I know I haven't really said this explicitly, the basic vulnerability that we are exploiting is just being able to copy an arbitrary amount of data into a fixed size buffer. So like an unbounded memory move. Whenever you can do something like that, copy a large amount of data into a buffer that's so small, you can often get arbitrary code execution by one means or another. And so by and large, buffer overflows are probably the greatest percentage of memory corruption vulnerabilities. There are other ones that we'll talk about, some like used after free. The Aurora vulnerability was one of those, and other stuff like that. But basically, just being able to copy too much data into one buffer is the source of most of these issues. In case it wasn't clear on where exactly the vulnerability was before. So in the, for instance, in the simple login program, the vulnerability is this gets call, because gets will just read in as much data until it gets a null character or a new line, basically. And so there it is, unbounded data copy. And with this one that you guys are looking at now, it's a string copy. The string copy often has no limits, right? So a safer version of this would be strn copy, which is, provides some limits. But that can have its problems as well. That's right. For those of you that chose the push method, one sort of nasty issue you run into is that at the point where you begin pushing the string onto the stack, ESP is often pointed at your shellcode. So when you push the /pencil string onto the stack, you'll actually be pushing data over your own code that's executing. You'll get a crash then. And it's really hard to debug because when you look at your shellcode in the debugger, everything will look perfect. And not until your shellcode starts executing, it's like polymorphic and crashes itself. So. Who else has gotten the basic vault exploited? You guys got that? Yeah. So there's a few of you. For those of you that are caring through the labs, I'm going to show you something you should check out.
You got to work in GDP so that it is more.
Oh, yeah.
So for Keith and the other guys that have gotten the one exploited already, I would challenge you to check out this like exploitation contest. That is pretty cool. There's a lot of servers out there that do exploit contests, which is basically kind of like what you're doing now, and just kind of like more and more challenging versions of that. You'll start at level 0, which will be a basic Stack Overflow, and by the time you get to level 20, you'll be doing some crazy, insane stuff to try to exploit something. And this is one of those games. Overthewire.org is a pretty cool community, and personally, I think their games are the best and the most creative, so they're the ones that I recommend. And the one most relevant to you for getting started, if you like this kind of thing, is the Vortex game. So, if you feel pretty comfortable with this material and you want to get better at it, I think this is a great way to do it. Each one of the levels is challenging, and you'll learn a lot more about bypassing exploit mitigation and stuff like that as far as playing the game. So yeah, if you go to overthewire.org, look at the Vortex game, it'll show you how to get started. And yeah, I recommend checking that out if you like this content.
Does it walk you through the stuff if you get stuck?
There's an IRC channel, and
Okay.
people are generally helpful there.
Okay.
So,
But it doesn't have the solution for it.
no, it does not. But the levels are very hard. They start out not so bad, but they quickly get quite difficult. Yeah. And a good place to like learn more about this kind of stuff, like exploitation material, is the Bragg magazine, for instance. There's a lot of underground magazines. This is the one that I think is especially good. It's been around for a long time, and a lot of the seminal exploitation papers have come out in this magazine. And it doesn't come out very often, and ironically, one just came out like a couple days ago, and they have all kinds of cool in-depth analysis of like exploitation and other stuff like that. So it's just a great place to get extremely technical knowledge on exploitation subjects. So Keith, for those of you that have already gotten the basic vuln exploited, I have a new challenge for you. That way you're not sitting there idly. You could be learning awesome exploitation material. And I'll challenge you to try to exploit this, which is fp_override.c that you would need to compile with TCC. And the problem here is that this is a off by one vulnerability where you can overwrite 1 byte past the bounds of the buffer, which means you can overwrite the least significant byte of the saved frame pointer, which is something that we have been up until now overwriting with BBBB. And just by changing that least significant byte, you can actually gain arbitrary code execution eventually.
Why just the least significant byte?
Because you're just able to write 1 byte past this, which points at the least significant byte of the saved frame pointer. I'm not going to make anyone else do that, by the way. That is pretty nasty. But I do outline how it is done in my day 2 material, for those of you that are curious. And the point of making day 2 is that even the smallest bug, like just being off by 1, can lead to a catastrophic failure of security.
So the exercise would be to just overwrite that buffer by 1 byte.
Now the exercise is to get your shellcode to execute.
Oh,
You get started on the off by 1 overflow, you can just try sending, 257 bytes at it, and it'll probably crash, I think, and you can start looking at the crash, figure out why it crashed, and then why it crashed might tell you why it might be exploited. There it is. So one thing I haven't showed you guys that I should have is that when you're doing your payload and you discover that your return address isn't working and you just want to change the return address without having to use the whole payload, you can use a hex editor to easily change the return address. So for instance, you type hex edit payload. I can see that this right here is the return address, that I'm trying to change. And then just change the bytes in here. So if instead of F573, I wanted to put 88, I can just do 88. And then just do Control X to save and exit. So if all else fails, guys, if you feel like your shellcode isn't working, I did put some shellcode in the .answers directory. So if you want, you can just use the binsh shell.pl, the .answers directory, and that should definitely work. So just to walk through that exploitation process, what I'm going to do is start exploiting the basic vuln with the binsh shell code. And you know, if you're working at your own pace, feel free to just keep doing that. But if you feel kind of lost or confused, just follow what I'm doing, and hopefully that'll help clear some things up for you. So the first thing I'm doing here, I'm just going to narrate this for like the remote users, for instance, is copying it into the labs directory where basic vuln is, just to keep everything in the same directory for organization. So there it is. There's the basic binsh shellcode, which should work. I'm just going to put it into a file for myself. All right, nothing magical about that. Compiling the basic vulns since I haven't done that already. So it's a 64-byte buffer again, and let's see how big my binsh shellcode is, just so I know how many no-ops I need. 45. So pretty big. So I just have what was that? 19 bytes of no-ops, basically. How many of those? No, it's 19. So let's start building my payload. First, pad out everything with no-ops. So first are the no-ops, then after I do concatenate the binsh shellcode on there, it should be 64 bytes total to completely consume that password buffer. So yeah, there we go. 64 bytes. Kind of tack on 4 extra bytes for that overwritten save frame pointer. And now I need to know what my return address should be. So this is one of the trickier parts. So I'm going to open up basic vuln in GDB. I'm going to set a breakpoint for after the string copy, because this is where the payload enters into the process address space. The string copy from that first command line argument, that local buffer. So breakpoint for me plus 27. For this program, I have to use the backtick cat payloads, backtick substitution operator. Okay, so I hit the breakpoint. At this point, I want to scan the stack for my payload so I know what to use for my return address. Okay, and I can see my no-ops are in here, starting at OXBF, FF, F518, you know, these OX90s, up to F20. And just like I was telling you guys, I want to pick somewhere in the middle of the no-ops to give myself enough wiggle room. So I'm just going to do BF, FF. I'm avoiding this address for a reason. Can anyone tell me why I don't want to use this address? Out of curiosity? That's a really hard question, I will tell you. Because OX20, which I would have to write, is actually the hexadecimal code for the space operator. And that could cause some problems. This is going on the command line argument. So instead, I'm going to do OXBFFF F519. Actually, 9F. Yeah, minus 1. 20 minus 1. Yeah. Or 1. All right, I'm getting my hexadecimal stuff. So, OXPF, FF, F5, 1F should be in the middle of my no ops, so that's what I'm going to use for my return address. Doing it backwards because we're in Little Indian world. All right, so there's my payload. Up to this point is 64 bytes. That's what's going to consume that password buffer we're overflowing. Save frame pointer. Doesn't matter. Overriding it. Return address, which points to the middle of my no ops. Should be pointing like at this byte right here, basically. All right, now we cross our fingers and run it and see what happens. Oh no! These things happen, and it's good that this happened actually because I can show you how to debug the scenario. So, like I sort of have hinted at before, the addresses can be a little bit different in the debugger than they are when you run on the command line. And that's just because the stack shifts around when you're debugging things with GDB compared to if you're running on the command line. So, luckily, Linux has some functionality where if we enable it, when a process crashes, it will dump a core image, like basically an image of the process that was running, and then I can use that crash dump to see what the process was doing at the time it crashed, and it will help me see, give me a better picture of what the memory was during the crash, and then I can see how my addresses were off and what went wrong. So let's do that now. So here's the command to write down, guys. ulimit C unlimited. This command will cause Linux to dump these core images every time a process SIG phones. It's important when you're exploiting things and you have all kinds of crashes during your payload development process. And if I do that command and then run it again, you'll see the brackets core dump, which is telling me the core file exists now. And here's another command for you guys to write down. To use that core file, do gdb basic vuln as the core. But then for that second command line argument, add in core, which is just telling it to use the core file, which is the dump of the process's image anytime that it crashed. The dump of the process's memory, excuse me. Okay. So this gives me some useful information. First of all, I crashed on this OXBF-FF-F522, which is a stack address, right? So I might probably just jump into the middle of my shellcode or something like that. And Dave and company have already seen this one because their shellcode is getting clobbered by push instructions. So at this point, what I would want to do is inspect the memory at this address and see what I'm trying to execute here. And it should give you some insight into what's going on. Okay. So it looks like I guessed the wrong address and I didn't even jump into my shellcode. It looks like I, jumped into there somewhere above my shellcode. So let's hit enter again, which will let me look a little bit further. And that right there should be my my shellcode starting in group 3B. So what I'm going to do is just pick another address, try to get lucky again. So this time I'm going to pick BFFF537. So I'm just going to use the hex editor to go and change that address. I'll try again. Yay! We did it. So hopefully that'll give you a little tip for debugging issues when you see things like illegal image and that sort of thing. The core dump image is really useful because it shows you exactly what the process address space looked like at the time of the crash. That way, if your addresses are a little bit off, that will reveal, that will be revealed when you look at the core image. Okay, so out of curiosity, do you guys want me to let you spend more time on this? Would you rather me go ahead and move forward with other material? It's completely up to you.
Go ahead.
Press ahead? Yeah. Okay. You can do that.